In this video, we'll learn how to determine the best equation type for given data. Before you watch this video, it's highly recommended you watch the video LinReg, Getting a Line of Best Fit on the TI-83 Graphing Calculator. That is important because this video assumes you already know how to do a lot of these steps. First thing to do is make sure your calculator is turned on. Second thing to do, as in the previous video you watched on LinReg, is to clear the memory second plus 712. Once that's done, we're going to enter our data, stat, and then enter to go to the tables. And now we'll type in the x values, 1, 3, 5, 7, 9, and 11. And we'll type in the y values, 0.2, 2.6, 24.5, 225.1, 1,911.7, and 17,793.4. Take a moment just to verify, as I'm doing, that your data is correct. Just checking all my numbers. And you'll notice here the calculator only displays some of the data, but it's actually all there. That whole number I typed in, including the decimals there, just doesn't have enough space to display it. Okay, our data is all set up. Next steps, which you'll remember from that previous video, is to hit second y equals. Right now the tables are turned off, the stat plots, so we're going to hit enter and then hit enter again to turn them on. We also want to be able to zoom in on our points, so zoom 9 will show us all our data. Okay. Now we're going to make a linear equation, but we're pretty sure that's wrong. It doesn't really look like a line, does it? But let's quit out of here, second mode to quit. And let's do LinReg. You remember from your last video, hit stat, go over to calc, and then pick 4 for LinReg. Now second 1, comma, second 2, comma, and then vars, over to yvars, hit enter for function, enter for y1, and then enter to run it. Okay, we've got our equation. Let's see what it looks like, but already it barely registers. It'd be nice if we had a rating though, so we could rate it. So if you remember from that previous video, let's quit out of here, you can turn the diagnostics on. That's by going second 0 and scrolling down. Diagnostic on, enter, and now it's on the main screen, run it. It says, okay, diagnostic on. And now I want to run the previous command. I don't want to have to type that whole LinReg thing again. So hit second, enter. It gives you the previous command. Hit it again, second, enter. And there's my previous command. Before diagnostic on, LinReg. Hit enter and run it. And it runs the LinReg again. I get the exact same equation, but this time I see, well, it's 71% like a line. So it's okay, but we want a higher match. And again, just by looking at it, you can see this isn't the equation of a line. This table is probably not a line. So let's go back and redo the steps, but this time we won't make a line, we'll make a quadratic, a parabola. So hit stat, go over to calc, but this time instead of picking LinReg to make a line, pick QuadReg to make a quadratic. And again, there's other choices. We're just going to look at 3. Our first was LinReg, now we're going to look at QuadReg, but there's also other ones. So we tried line, let's try quadratic. We're going to do QuadReg, and just like before, tell the calculator my x's are in L1, my y's are in L2, and put the answer in equation y1. Run it. There we got it. So it says r squared is 0.85 approximately. So we'd have to square root that. Let's square root that to see what's the square root of 0.85. 92% like a line. I should say like a quadratic. We already did the line and that was like 71%. So it's better. Let's take a look. There's our quadratics. Okay, I like it. Ish. But I don't feel that it's that good. I mean, you can clearly see it doesn't follow all the points that well, but it's better than the line. And we can confirm that visually. We can also, let's quit out of there, we can also confirm that with a better correlation coefficient, 92% like a line rather than our 71%. Sorry, 92% like a quadratic rather than 71% like the line was. So let's try one more. And this one I'm hoping for. We're going to replace that equation again, this time with stat over to calc. But scroll down past the LinReg choice. It's not going to be a line, it's not going to be a quadratic. Let's try making it an exponential. Pick exponential reg. Once again, second 1, comma, second 2, comma, and let's replace that equation in y1, picking y vars, with an exponential equation. Replace it, run it. And we get, sure enough, an R of 0.9995. It's super close, more than 99% like an exponential. Let's take a look. It draws the exponential equation. You can't even see it. It's hitting all those points and then boom, and hits everything. I mean, it's a perfect choice. Near perfect as you can get anyway. So what's our exponential equation? Hit y equals, and there it appears in the graphing calculator. Y equals 0.078 rounded to the 3 decimals. So that's this whole thing. It just took the first 3 decimals rounded times 3.091 to the power of x. And if you don't want times, you could put brackets. But we tried a few choices. We tried the line, we tried the quadratic, and we tried the exponential. And not only visually, but also using the correlation coefficient, we're pretty confident that the best equation for this data that we were given in this table was in fact the exponential.